Hi students, I am your instructor. From here you will learn the application based mathematics, and by this way you can easily complete the basics of your whole mathematics syllabus within 2 months. So let's start. Today I will discuss about the basic mathematics based on NCERT syllabus class 10. The basic goal of this presentation to teach every student willing to learn mathematics. Learn mathematics is a tool to create our life better. And remember one thing, great does not mean you are not good enough to do it. So our today's agenda will be like this. Firstly, I will go through the NCERT board syllabus and its category. Secondly, the exam paper patterns. Then I will discuss some chapters and its mathematical applications. And finally, I will conclude by giving some questions. There are 15 chapters in class 10 mathematics syllabus. I have categorized those under the main branches of mathematics. So have a look at the chapter's name starting from real number till probability. Today I will go through the details and discuss about first 5 chapters. Topic wise, our mark distribution will be like this: number system including 6 marks, algebra 20, coordinate geometry 6, geometry 15, trigonometry 12, mensuration 10, statistics probability 11. So total marks, that is 80. In question pattern section, we will notice question wise marks distribution. Section A consists of 3 types of questions, each will carry 1 marks. Total number of questions is 20. 10 questions of multiple choice, 5 questions of fill in the blanks, and 5 questions of very short type. In section B, there will be 6 questions of short answer type and each will carry 2 marks. In section C, total number of questions for long answer type is 8 and each will carry 3 marks. And lastly, in section D, there will be 6 questions for very long answer type questions and each will carry 4 marks. So total paper is of 80 marks. Now comes to the one important thing, keep in mind for your class 10 exam. You have to complete section A within 35 minutes, section B within 25 minutes, C within 50 minutes and section D within 55 minutes. And your revision time will be 15 minutes. Now our first chapter, number system, which denotes notation or standardized unique representation of the quantity. There are many applications in number system. This category can be utilized in counting elements, percentage calculations, probability calculations, and measurement of length. Let us take the 2 examples to find out the applications. To find the number of atoms present in a molecules, we have to know about whole number or what is whole number. Or in case of another great example, if we want to know the height of a boat, everyone will say 0.5 meter. But if anyone wants to know the depth of the water, so it will be mentioned with -5 meter. There we have to use positive and negative sign for representation or usefulness of integers, that can be positive or negative. So as we know, any number can be plotted on number line or graph paper, like means with respect to x or y axis, that is real number. That means that can be 0, 1, 2, 3, -2, -3, -4, any negative number. Root 2, that is equals to 1.4142, like means value of pi, anything that can be plotted on our graph paper, that is real number. From this slide, we will learn the total concept of real number system. We will start with natural number, which is denoted by a capital letter N. any number like 1, 2, 3 is natural numbers. For example, if anyone asks me how many players are there in a football ground, my answer will be 22, which is a natural number. Next, move to whole number. Whole number can be denoted with capital letter W, and where it will be used? If someone asks me what is the score of a match, we will say 23 with no loss. So there is the importance of using 0, and we will say that is whole number. 0 included with natural number 1, 2, 3, 4 is known as whole number. Now we will denote integers with capital letter Z, and it's include all the positive numbers like means +1, +2, +3, all the negative numbers -1, -2, -3 and so on, including 0, that is integers. If +1, +2, +3 are positive integers and -1, -2, -3 and so on are the negative integers. When a number can be represented with a by b form and where b is not equals to 0, then this type of numbers is known as rational number. And where it can be used, like if we say portion of a pizza or 10% discounts, like means 3 by 7, 5 by 2, 1, 3 by 10, any this type of number is known as rational number, as denoted with capital letter Q. Real numbers are basically two types. One is rational number and other one is irrational number. We have already learned about rational number. So what is a rational number? It can be denoted with capital letter I, and it is non-terminating decimal numbers, long decimal numbers, like value of pi 3.1428, like √2, √7, √17. These are irrational numbers. I think as of now all of you will get a clear idea about real number from this given picture. In Euclid's division lemma, if we take a as dividend and b as divisor, now if we divide a by b, and we will get r as remainder and small q as quotient. Now satisfying the equation, we will get a equals to bq plus r. This state the principles of Euclid's division lemma. So what is an algorithm and lemma? Algorithm states a series of well-defined steps of problems, and lemma is proven statement. Now, how Euclid division lemma is useful to us? Euclid's division lemma will help us to compute HCF, and if we want to cover our rectangular floor with tiles, so we can identify the number of tiles needed to cover the floor. Please follow the example for better clarification. In this points to remember section, I will tell you the important notes of this chapter. As we know, decimal numbers are two types, terminating and non-terminating. Terminating numbers have finite numbers after its decimal place, and non-terminating decimals are non-periodic in nature. If p by q is said to be a terminating number where p is numerator and q is denominator, then p and q should be coprime and q should be in form of 2 to the power m and 5 to the power n. Our next point is on fundamental theorem of arithmetic. It states that every composite number can be expressed as a product of primes. The product of HCF of two numbers and LCM of two numbers is equals to the product of numbers. All we know. Here are some important formulas of HCF and LCM with some examples of repeating numbers. Some important questions are given here covering all the topics of this chapter. Try to solve it. Now move on to our next chapter, that is chapter 2, Polynomial. Any type of algebraic expressions with variables are called polynomials. In a single frame, if we break the polynomial into two parts, we know poly means many and nomial means terms. So we have many terms. Now, if we have the polynomial with highest power of a variable is 2 in an expression, that is quadratic. If highest power is 3, then known as cubic polynomial, and so on. Please follow the standard form of a polynomial and give an example. Here's some real life applications on polynomials are given. We can use it in our construction section, healthcare, and also in physics to describe the trajectory of projectile motion. By using this given equation, we can create our own roller coaster model, where x represents the lengthwise measurement and y represents the height of the roller coaster. In points to remember section, I will highlight the important parts of this chapter. Now, if someone asks me what is the basic difference between function, expression and equation. So, when we represent polynomial with respect to fx, then it represents function. And if it's equals to 0 or anything, then it represents equation, and in simple raw form of polynomial, like means x square plus 2x, that is known as expression. If alpha and beta be two zeros of a quadratic polynomial, then x minus alpha and x minus beta are two factors of the polynomial. Now, x square plus b by a x plus c by a equals to x minus alpha into x minus beta. Comparing with both the two sides, sum of the zeros equals to minus b by a and product of zeros equals to c by a. And in case of cubic polynomial, sum of zeros equals to minus b by a, sum of zeros taken two at a time, that is equals to c by a, and product of zeros equals to minus d by a, where alpha, beta, gamma are the three zeros of the polynomial. Division algorithm for polynomial quite similar as Euclid's division lemma. It states that if px and gx are any two polynomials with gx not equals to 0, then we can find polynomials qx and rx such that px equals to gx into qx plus rx. Please look at the example and try to solve it. The number of zeros of a polynomial in graphical representation precisely means that number of times it touches the x-axis. Hence, look into the figure on the graph and its respective statements. Here are some important questions. Please try to answer, which may covered all your topics from this chapter. Chapter 3, pair of linear equations with two variables. When we deals with two variables in a single equation is known as linear equation, and highest power of the variables is 1, then this will represent a straight line and it's known as linear equation. Hence, ax plus by plus c equals to 0 is the general form of linear equation. If we deals with two linear equations it known as pair of linear equations. Pair means two. We can plot any linear equation in a graph paper. If there are two linear equations and they intersect each other, after solving the equations, there will be one solution. Means one value for x and another value for y. If both the straight lines placed parallel to each other, there will be no solution. Then there is not possible to solve the equation. If both the straight line coincide each other, there should have infinite solutions. Means x and y has so many solutions or values. Now we have a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0 are two pair of linear equations. By comparing both two equations, if a1 by a2 equals to b1 by b2 but not equals to c1 by c2, then it's said to be the given equations represents two parallel lines and it never meet at any point. Hence, it has no solution. If a1 by a2 not equals to b1 by b2 not equals to c1 by c2, then it's said to be the given equation intersect at a single point and it has only one solution or unique solution. And when a1 by a2 equals to b1 by b2 equals to c1 by c2, then it represents coincident lines and infinite solutions. Please read the note given below. There are so many applications of linear equations in our real life. Starting from one of the real life approach of linear programming problem solving or formulating a real world problem to linear equations. In this given example, Mr. Rai have two choices, plan A or plan B. From the given equation, we can understand to ride more than 5 km, he will choose plan A, but if he ride for less than 5 km, he should choose plan B. Please try to understand the graphical representation. Likewise, plan cost estimation, estimate budget planning, we can use linear equations. Hence, we can also use the linear equations to find out the speed limit of each route and can maintain the traffic system so that accidental damage can be minimized. Disease trend analysis can be performed by using correlation and regression model, which is also related with linear equations applications. Now, if slope of the line trending low to high, considering from origin, this will be positive correlation as shown in the below given figure or figure number 1. And if it moves from high to low towards x-axis, then this will represent negative correlation as shown in the above given figure or figure number 2. So mathematically, in case of positive correlation, x and y are in simple proportion, and in case of negative correlation, x and y are in inversely proportional to each other. I have given some information into the given page. Try to understand the given objectives of LPP or linear programming problem model and core values of graphical representation. If we have two pair of linear equations a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0, then we can solve it by using any of the four methods. These are comparison, substitution, elimination, and last one, cross multiplication method. But in our most of the books there are three types defined in your syllabus. These are substitution, elimination, and cross multiplication. Comparison method is not there. I have given some examples for each of the methods. Please try to understand. As mentioned earlier in points to remember section, I will highlight the important parts of that chapter. I have given an example to prepare a general equation from a word problem, as taking a real life scenario. Here I also highlighted some of the necessary points like equations of the parallel lines to the axis and its graphical representations, relation identified from the two pair of linear equations, and calculating area of the triangles from a graphical plot by using area equals to half into base into height. Here are some important questions covering all the topics of this chapter. Try to answer. Chapter 4, Quadratic Equations. Any second order polynomial equations with single variable is known as a quadratic equation. A quadratic equation can be represented as ax square plus bx plus c equals to 0. According to the Sridhar-Acharya's formula, discriminant equals to b square minus 4ac. By using this rule, we can identify the nature of the roots, or simply we can understand the pattern of the values for x. If d equals to 0, it has two equal roots, and if d greater than 0, it has two distinct roots. Respectively, if d less than 0, it has imaginary roots. Please follow the given solutions. Here some important applications of quadratic equation are given based on real life examples. We can use it to calculate projectile motion. Secondly, to define the shape of different two-dimensional figure like circle, parabola, hyperbola, ellipse, etc. Please follow the given examples for better clarification. Here are some of the major highlighted portion of quadratic equation as used in projectile motion. To launch any missile from the particular coordinate position of the Earth's surface, as military personnel or NASA can calculate the flight path of the missile, which is really a good example to understand the quadratic equation. In this section, I have shown two types of equation solving procedures. Number 1, factorization. Number 2, Sridhar-Acharya's rule. I have also given both types of examples with quadratic equation, related word problems and its solution. In this points to remember section, I have highlighted the important parts of the chapter. From here, we can understand how can we define a quadratic equation. Roots, zeros or values of variable are the same things, and please follow the useful formulas. Here are some questions from quadratic equation chapter. Try to solve it. Chapter 5, Arithmetic Progression. In this chapter, we will learn how can we find a missing numbers from the well-ordered pattern. As we know, sequence is a set of related events or items in a particular order, and when the terms of the sequence follows a certain rule or pattern, that type of sequence is known as progression. Here we will define three types of progression. These are arithmetic progression, geometric progression, and harmonic progression. But arithmetic progression is only included into our syllabus, so I will only discuss about the arithmetic progression. It has various real-life applications as follows, starting from basic utilities in theater seat arrangement, building a ladder, and up to the analysis for the investment plan. In this section, I have mentioned the general form of arithmetic progression. If A1, A2, A3, so on are in AP, or we can represent it in form of A plus D, A plus 2D, A plus 3D, so on are in AP, considering both the sequence, we have find the any term from the sequence or nth term and the sum of the sequence or Sn by using the given formula. If our sequence is starting from 1, 2, 3 and continue up to n terms, then It can formulate the sum as n into n plus 1 divided by 2. This sequence first observed by the great mathematician called Friedrich Gauss. I have given the example how did he solve that problem. We can also calculate the height of each cross section of the terrace. Please follow the given example for better understanding. In the points to remember section, I will focus on the basic formulas and important notes of this particular chapter in summarized form. One important thing should always keep in mind: if the sequence is ending with some values, it's known as finite series. If it is continuous, then the sequence is to be considered as infinite series. Here are some important questions. Please try to solve it, which may cover all your useful topics from this chapter. So, I am concluding for the time being. I think this session will help you out in many aspects. Keep in touch with me for more videos. Contact me for any query in my email ID.